So let's do one more thing while we're here, and that is using a similar thing to our random strengths here. I want to randomly break down some of our pieces. So from here, we had I guess we had 100 pieces or so, 102. That's fine. I'm going to make a for loop and iterate over, or for each rather, for each, or not the subnetwork. I want to say, hey, let's look at each of the pieces, and for some of them, again, based off of that random kind of thing, for some of them, let's do another Voronoi and break them down. So let's put on single pass for a second, and you can see the individual pieces. So it's looping over these, and this is just a good debugging thing, is this single pass option. Otherwise, you can just go to this one. It'll just show you the last iteration that it did. But let's just choose this one, and let's just find a good example piece. So say like this guy here is good. So I'm going to say, I'm going to make a switch. Oh, let's say I'll make a placeholder here. Here's a null. And we're going to say, hey, sometimes switch to that side and do that thing instead. So in a similar manner, we're going to make a rand, but we don't have a prim number thing to base this off of this time. Let's instead, we need to know, let's base our random off of the current iteration of the for loop that we're on. It's doing apparently 69 loops on this. The loops are based off of the name. And the name is based off of what the Voronoi decided was the name. When it did its original fracture here, it made a whole bunch of pieces. So here we are. And I'm going to say, click on this guy, say create meta import node. The meta import node has some cool stuff on it. It tells you what iteration you're currently on, stored in this detail attribute. It tells you the name of the iteration, which in this case is based off of this piece attribute. And then it tells you the total number of iterations. So here we are with that. We want to use the iteration value. So we're going to use the detail expression to access that. So we say detail, and we point to the actual metadata thing here. We ask for the iteration that we're on, and we want the 0th component of it, which is just the value. If it was a vector, you could put 1 or 2, but it's just a float, or rather an integer, so that's fine. So with that information, we'll say, well, give me a random number based off of that. Okay, now it's going to get us a number between 0 and 1, but the input can only be an integer. So let's say, hey, if this value is, again, let's say less than 0.25 rather, then sometimes, 25% of the time, it's going to choose this side. And to demonstrate that, I'm going to say sometimes make it be red. So now if I come down here and I turn the single pass business off, 25% of the time it operated on this side. And if we go through the single passes, you'll see, we'll find a red one, there's one. You can see how the switch changed. See, on this one it was this way, and this one it's on that one. And that's just because apparently on this iteration, the random number based off of that was less than 0.25. So of course, we're not that interested in changing the color. What are we interested in? We are interested in, we don't really need that there anymore. We want to just subfracture it. So let's scatter some more points on this. And these are small enough that I don't really care if the points are inside or not. So I'm not going to do the whole ISO offset to noise and all that jazz. These are going to be small, so who cares? I'm going to say make it based off of the density of the thing. So for a piece that size, I want around this many points. I see that it's making 3 points with a density of 6. And the density is based off of the, surface area or volume, or, depending on what you're putting into it. But again, 3 points is fine. So now if we look at it, you'll see some of these will be replaced by points. So these points are going to create our subfractures. We may end up even needing more, but let's just try this for now. So let's put a Voronoi. We'll put it here or whatever. We're going to take the piece that we're currently working on, and we're going to give it the points that we just generated. And there you go. We might actually, this made nothing here, because apparently on that phase, this density was so low that it actually didn't even have any points to make anything. So let's try to, let's actually turn on the visualize pieces for this. Cool. You can also always change the global seed on this to get different results. It seems that many times we're getting nothing. So I would also say, let's add another step into this. Let's say if it's less than that, and if our scatter is even generating points, scatter 3 it was. So we'll say, and the number of points from scatter 3. Oops. If the number of points it's generating are greater than 0, there we go. Now we're not getting that error anymore. So now it's not even going to try to do it. It'll check first to see if this random situation is even satisfied before it does the other thing on the other side of the and. So if it was going to do it, then it says, how many points did you make? Oh, nothing? Well, then forget it. So you can see some of these pieces got subdivided into these smaller pieces. And as I was showing with the scatter here, by changing this, we'll get different distributions within it. We can also change the distribution of where they are by changing our random pattern here. I'm just gonna, so it based our rand seed here off of the current iteration that we're on. If I just add some arbitrary number into here, it'll be a different distribution altogether. All right, well, before we move on, I just wanted to step through maybe a little bit of a debug to see why we're getting that thing there. Let's see, let's try to isolate, let's try to find one of those that's not showing us anything. So apparently, I guess the output is giving us nothing for one of these. So I'm just going to step through these real quick, see if we can find one where it's blank, and then we'll know. Oh, I think that was one. So 33 apparently, the middle click, yeah, it's yielding nothing. So why are we getting nothing? Well, it's starting with a piece. It's getting to here, which is making 1 point. So I wonder if maybe 1 point is not enough. So this is all of a sudden yielding 0. So I'm going to change this switch thing here. That's probably all it is. I'm going to say, not only to be greater than 0, you got to be greater than 1. So there we go. So now we won't have that problem anymore. Yay! So now we can middle click and drag on this seed net thing here. So I'm basically choosing this number. And as I change the number with the ladder, you can see we're getting different distributions on there. Pretty cool. And if we're feeling really bold, we can even increase this to 24 so that it's creating more pieces. Whenever it's subdividing, it's making lots of pieces. Cool. And now that we're feeling good about how many it's doing, maybe even we could be a little more aggressive with how often it's doing it. So I'm going to change this to 0.4. So now it's going to do it 40% of the time. So you can see how you can build up little tools like this to make some cool stuff. Great, so turn off visualize pieces once again. We can pipe that into the assemble now. There we go. So now the assemble is going to create 379 pieces, which is, I mean, it's fine. Again, we're using packed, so it's not like we're going to run out of memory, but you do have to remember that the more of these we do, the slower the sim itself will run, but, it'll still be pretty fast because Bullet is still pretty fast. So this is nice. So now we can see we have some featured pieces, we have some nondescript pieces, we have some big pieces, and some small pieces. This blast won't make any sense anymore because we were deleting primitive 314, which won't be the same primitive that we expect, so we have to get rid of that now. So here's our new constraint network based off of all those pieces from before. These pieces are so big on this side, I guess, that we don't see any constraints, or we don't see that many constraints anyway. But just to make sure, maybe we'll increase the connections a little bit because we do have a lot more pieces now that are clustered close to each other. Cool. And I can almost see the pig head coming together. The more pieces we have, the more it's kind of converging on that. Everything else kind of filters down, of course. Like this will still, 10% of the time make super strong connections. Everything propagates down, of course. Now when we drop it, we have more pieces. Now we have little ones flying up. We've got really jagged things going on. And it's still super fast. Great. Really getting more detail. And you can imagine, just keep pumping those numbers up, keep getting more and more complicated stuff. You can use noises to change. Like we used a random function here, but you could use a noise to change the strengths all over it somehow. I feel like you don't really usually need to do that, but do whatever you want. So there you go. So that's it for constraints, and now we're just gonna move on to the conclusion. We're gonna have a whole bunch of these rain down, and we're gonna render it, and then we're done.